Alright, welcome guys. This new chapter talks about estimating with confidence, in particular with a confidence interval. Instead of estimating something to be just one particular number, we do it with an interval so that we have a little wiggle room in case we're wrong. Here I've got the formula for a confidence interval. In particular, we're going to start off just estimating the mean of a population. This formula maybe looks a little ugly, and we're not going to do it by hand if you don't want to. I'll teach you how to do it with Excel. A confidence interval is just essentially a point estimate, so one particular number that we're estimating a value for, plus and minus margin of error, how off we're willing to be. Okay, so that gives us a little wiggle room in case our one single estimate is off. We choose a confidence level, which is related to the distribution, which is 1 minus alpha, between 90 and 99%. Starting with example 1. Let's define our random variable of interest, figure out its distribution, and the parameters. We see we took a random sample of 32 food bags, and we're looking at the average weight of those. Therefore, our random variable will be x bar. X bar follows a normal distribution. We know this by the central limit theorem, or by CLT, the central limit theorem, because our sample size is more than 30. We have a large sample, therefore the distribution of x bar, or the sampling distribution, converges to a normal distribution, with a mean equal 4.08. Standard deviation of x bar is the standard deviation of the population divided by the square root of the sample size. That's part A. Estimate the mean weight of all food bags using a point estimate. So we're going to estimate the mean weight of all food bags, so population mean, use the Greek letters, using a point estimate. The best point estimate for the population mean is simply the sample mean, x bar, the 4.08 pound. Part C, we're going to estimate with 96% confidence the mean weight, so what we just did in B, but now with a confidence interval. Instead of one single point estimate, we'll use a confidence. Here's the formula that we have. So we can go through this calculation by hand, which is what your textbook shows, but I want to show you how to do that in Excel. Again, every confidence interval begins with a point estimate, and then plus or minus this margin of error. Our point estimate we just found in part B. X bar to the 4.08. Now I just need to figure out this margin of error. Excel has a quick, easy formula to compute the margin of error. I've laid out the steps here, but I'll just go ahead and show you in Excel. The formula is confidence.norm. The first argument is alpha. I'm going to flip back to our problem here. The confidence level, by definition up above, is 1 minus alpha. So here, 1 minus alpha equals 0.96. Therefore, alpha must equal 0.04. The standard deviation of the population. And then the sample size, 32 food bags. This number here is my margin of error. I'm going to call it M for margin of error. Now to compute the interval, x bar plus the margin of error is my upper bound. X bar minus the margin of error is my lower bound. X bar plus margin of error is the upper bound. X bar minus the margin of error is my lower bound. I'll do the math quick. Upper bound, lower bound. And 4.0473. To interpret this, we are 96% confident that the true mean weight, or the population mean weight, of all the food bags is between 4.047 and 4.113 pounds.